So, hello together to my lecture in statistics, and I gave you the last time some exercises, and now we want to do these exercises today together. First exercise, we have the education sector, or we look at the higher education level, which we can reach in different sectors: industrial sector, agricultural, public, financial, or trade sector. And the other attribute, so here one attribute is different sectors, sector of qualification, and the other attribute is gender, so man or female. And with this data we have here, so 5,256 men reached in the industrial sector, a higher education level, and so on, 3,221, 1,001. And here are the numbers for the women. And having this data, we want to calculate the relative probabilities. And from this relative probabilities, we want to calculate the cumulative probabilities and the contingency table. And in the end, then on a descriptive way, we want to decide if these two attributes, sector of qualification and gender, if they are more or less independent or not. This is a question we want to answer. So then we take the data, and this, of course, we will do again in Excel. So I open my sample file, and this is here. Then we switch over here. So that you can see this. And have another sheet. Here we go. So we have male, female, and we have sector of qualification, industry. What else do we have? Where's my exercise? There. It is agricultural, public, financial, and trade. Agricultural, public, financial, and trade. And now what we are also maybe learn here in statistics, I hope this will work, that how to get the data out of some file, quite often an PDF file, into our software package. So we see it, and then you just go on, and this is always a try and error because you don't know the format of the PDF file. So let's see if it works or not. Yes, it works. So this is a way how you get quite easy the data out of an PDF file. Just try and copy it, and then you are there where you want. So let's put it over here and here. No frames. So first of all, we want to calculate the relative probability. So what we want to have here, the relative probabilities. This means what is the probability here at this point to be in the industrial sector. There, we first of all need the cumulative number. How many people work in the industrial sector? I need the chat. Is it there? So, what is the number of people working in the industrial sector? Very hard question. Yes, this seems pretty well. I have to fight with my monitors. This is also new. If you have to make a new setup of all of your hardware. So just 5,200 and anything plus 9,982. And again, this we can take down, and we have all the people which are working or which make their education in the different sectors. So how many people are male? What are we doing? 12,000. This seems pretty well. And here we just make it sum of all these numbers here. Oops. And we go to the other side. Oh, you don't see the formulas. I just see. So we have to go here, and hopefully this will work. Yes. So, and now you see the whole setup. So, how many people do we have? So we need the total number of our sample. This also seems pretty well. So we just add these two numbers, and of course here it is a software package, but that you see that we are right, we can also of course sum up these numbers, and we should get the same numbers here. Fortunately, we make it. So now here the descriptive probabilities from our sample. What is the probability in the cell to be male and doing the education within the industrial sector? Just from our sample which we have drawn. What do I have to calculate? Maybe you don't give me just the result, but what you are doing to obtain the probability to be male and educated in the industrial sector from my sample. What do I have to do? This is just the relative probability to have two specific values of my two attributes, male and industrial sector, out of the whole sample. Yes, of course. Great. So, oh, this is just the question. This was your original data. This you generated. And then just somebody asked you, okay, now I want to know what is the percentage of guys who are male and educated in the industrial sector out of your total sample. And then, of course, I have to divide this number by this number. So it is this number divided by this number. And now we want to do this, of course, with all numbers within our table. And in order that we are able to copy it, we have to put in here our dollar signs. And then we can go down here and we switch here. Where is it? Percent. And it should be with 1 digit. I think this is enough. So these are all the descriptive relative probabilities. And now we are calculating here the cumulated probabilities to get our contingency table. So now we just ask, what is the probability to work or to be educated in the industrial sector? This we have to put in to this cell here. What do I have to calculate at this point? Great. And I say, or we just do it. So this and this, of course, we also want to do with all other points. And here, maybe one trick, if you don't want to go with your mouse up here and writing the dollar sign, you just can put F4 and then you get automatically 2 dollar signs. And it's even better if you push 2 times F4, $1 in front of your letter vanishes, and second, the other way, the dollar sign in front of your number vanishes, and again, no dollar sign and then 2 dollar signs. This actually I learned, I think, 8 years ago from students in my statistic course I gave in Frankfurt when I was at the university in Frankfurt, a lecture. And copy it. And now we can also with this painter here just copy the format from here to here. And then, of course, the other probability would be this, divided also by the total number, F4, zap, zap, zap. So, and of course, we can also calculate it in another way. Of course, we can also calculate to sum up just these probabilities. Let's see if it works. Plus this, because since we got these probabilities, we at first divided by the total number. And then, of course, it is a linear transformation. Therefore, you can then switch both calculations. First add and then divide, or first divide and then add. Okay, so these are now the, I will also call it descriptive relative probabilities. These are the cumulated probabilities. And now, of course, up. we want to ask are from our descriptive analysis, these two attributes, gender and industrial sector, are they depend on each other? And for this, of course, if I just copy it here, then he just switches and he takes only the formulas. And then, of course, since in this cell we have a 0, all my formulas give me the result of 0, of course. And therefore, what I now know I want to have is these cumulated probabilities only. And therefore, you go here, copy, right mouse click, and then put in the numbers. Then he doesn't take the formulas, but he takes the numbers. And if you click in here now, you see that you everywhere have the numbers. Then we cancel this out. And now we calculate the theoretical probabilities with the assumption that both attributes are independent. And just remember, this means that we can just multiply these cumulative probabilities. So in this cell, we have to multiply 0.7 times 0.38. So we do it. This and this 0.7 I want to have in all these cells here, and therefore I have to fix this number, of course. So again, 0.7 times the other cumulative probability, and we go down. And now if you click in here, you see I still have the B25 at this point. And then in order to calculate these, 0.28 fixed times cumulative and down here. So, and in the end, we have to compare our theoretical relative probabilities with our descriptive relative probabilities. And if these probabilities quite close, of course, we have drawn a sample. It's a finite set, so they won't coincide anyway. But if we would have here more or less these numbers, here we maybe have 30, here we would have 70.8, 17.8, here maybe 13%. If these numbers and these numbers would more or less coincide, then we could say that both our attributes are statistically independent. Or this we will do later in our course when we do estimation and do hypothesis testing. Then from this table, we pose the question, what is the probability to a level of let's say 95% that our two attributes are really statistically independent. But right now we are just in the descriptive analysis, and here we have the first look, and we just say, well, do these numbers coincide or not? And then you can make a first guess. If these numbers are quite close, you would say, well, I think they are statistically independent, but we see here on this level, well, they differ quite a lot. 0.5 percentage points also 5 percentage points, 4 percentage points, and so on. But if you later on formulate your hypothesis, I think to a certain level, these attributes are statistically independent. There you have to be careful, because if you can decide from your testing analysis, the answer highly depends on how large is your sample. Because these numbers here could really differ quite a lot if you have only a small sample of about, let's say, 15 or 20 guys. Then still your testing could give you back that on a level on 95 or 99%. You have still to suppose that these numbers are statistically independent. But there, for these cases, we also will do some examples. Okay, this was the first question. Then we go to the second one. Again, I have to look for my exercise. Where it is. No, this is a lecture. Oh, here it is. So we have done this. Oh, this was my funny question. Do you have thesis already maybe in school when you proved the Pythagoras? But Pythagoras you know, oh? So let's do it at first. We have to show this. Just xg equals, so the geometric mean is just the geometric mean out of the harmonic mean times the arithmetic mean. So I think I will do this just by hand. Then let's go here, and I take my laptop. Oh, no. Okay. Hopefully it works. I told you I have to learn. That's no. This is not good. Now it's okay. So first, xg equals square root out of xh times xa. Well, how to do it? We just put in our numbers. Let's say we have two numbers, p and q. Later on we will do the Pythagorean. Therefore I take just for the parts of the hypotenuse p and q. I think this you also have seen in school. And then we put it in. We have xa equals 1/2 p plus q, q, and xh equals 2 over 1 over p plus 1 over q, and we have xg is square root of p times q. So I think the first thing we do here from this formula is quite clear. We square it, then we get rid of the root, and we have xg squared is xh times xa. And now we put in our numbers. So we get p times q equals 2 over 1 over p plus 1 over q times 1/2 p plus q. The 2 cancels, and here we get 1 over p q over up p plus q. Did I do anything wrong? Times p plus q, because now it doesn't cancel out. Where's my fault? Two over this, 2 over this. This morning I calculated this and everything was right. There's my mistake. XH, XA. Oh, here is it. No, it is not. That is. Oh, here is it. Do you also find my mistake? What did I do wrong? I've seen it. This is always funny because in my lectures I'm so ambitious that I always want to calculate it directly and not to look always in my sheet of paper and just write it down, because then I could give you directly the solutions. Then you don't need me if I only look at my sheet of paper. Where's my mistake? Let's say this is 1, this is 2, and this is 3. 1, 2, or 3. Where is my mistake? Hmm? Here's my mistake. I have to do it the other way around, of course. The denominator of these is, of course, p times q and not p plus q. So this is hopefully the rubber. Yes. And we obtain, of course, p plus q over pq. This cancels out, and we obtain 1 over, this is now important, this is the large division and this is the small division. And then we obtain, of course, p times q, and this is xg squared q e d. Here we go. Then let's go to our picture here. This should be the half part of a circle. And now we have here p and this is Q. So this I think you also have shown in school. If I draw a triangle within this circle, then this triangle has to be rectangular. This is the theorem of Thales, I think. Class 8 or 9, you should have done it. Okay, if this is the midpoint of our circle, then of course this line here has to be XA. This is just the middle of our circle. If P plus Q is the diameter of the circle, then of course XA has to be 1/2 P plus Q. So this is the height of our rectangular triangle. And from this you also have done in your 9th class, the height of a rectangular triangle is just the parts of the hypotenuses, P times Q. Shall we show it? If you say this is A, B, and all this should be C, then of course we get A squared plus B squared is C squared. But we have also here a rectangular triangle. So we have from A squared also B squared plus H squared plus here is also a rectangular triangle. So we have also Q squared plus H squared. And of course, C is just P plus Q. So we obtain P plus Q squared. And this is of course P squared plus Q squared plus 2pq. So this, this, and this. And we obtain 2h squared is 2 pi q. Cancels. So here we have to take the square root. H is square root of pq. And this is nothing else than the geometric mean of these two numbers. And now the funny thing, if we take here also the height, then this line here will be the harmonic mean. And now we are almost half time, and because I also want to do some more relevant statistics, I give this again to you to a homework, but I will show you how you can do it. Because you also have here a rectangular triangle, you have here a rectangular triangle, and you have here a rectangular triangle. And you know also that this line here is just 1/2 of P plus Q minus P. This will also be helpful. Why is it nevertheless relevant for the statistics? This is also known as the geometric mean theorem. Because from this graphics here, from this diagram, you can, of course, deduce this formula here. That the geometric mean is, this is the funny thing, the geometric mean of the arithmetic mean and the harmonic mean. Okay, let's go on. Next question. Within a manufacturing process, we have on average 75% of our tools are correct. Calculate the probability that within a sample of n of 12 tools, you have exactly 3 correct tools. Which distribution we need in this case? So to speak, you have 2 results. Your random variable can be correct, 1, or can be not correct, 0. And we are drawing out of a total sample of 12. We ask what is the probability that we just take by random 3 of the tools out of this sample of total number 12, the probability that my 3 tools which I have drawn are correct ones. Because from the whole sample, let's say 25,000 tools, I know out of 25,000 tools, I know 75% are correct. Which distribution? Um, yes, great. So, how can I do this? Snapshots. There. Okay. And then we go here. Maybe I add first because we need it further. And this must I have to do again. Zip. Okay. No. Here we are. Our question. So binomial distribution means just that our probability is sum. Oh no, not sum. Of course. N. Okay. No, the probability is not. The sum is wrong. I need only the probability to have exactly these numbers, the 3 correct tools means then is k number of successes over n times probability to be correct times k times 1 minus pi n minus k. And this, of course, we put just in, so we obtain 3 over 12 times 3 over 4 to the power of 3 times 1 over 4 to the power of 12 minus 3. So we will do this in this case that you see it really slowly. So we have 12 faculty over 3 faculty times 12 minus 3 faculty times, and here we have 4s, so we have 4 to the power of 12 and 3 to the power of 3, and here fortunately we have 1, and 1 to the power of 9 is of course again 9. So we obtain 1 times 2 times 12 over 1 times 2 times 3 times 1 times 2 times 9. So this and this cancel, this and the 3 cancel. And here from 4, 3, 4, so 4 to 9 cancels. So this cancels here. Hopefully I have be right. So this is left and 10, 11 is left. So we obtain 10 times 11 times 3 to the power of 3 is 927 over 2 times 3. So again here cancels. And the 12 I left. This is 9. This is 5. And I forgot 4 to the power of 12. What else can we calculate? So 11, 5 times 11 times 3, and then here 11, 3, so 15 times 11 over 4 to the power of 11, 15 times 11. Means 165 over 4 to the power of 11 will be roughly equals 165 over 4 to 11. And oops, or in percent. Oh, 0.004%. I think it is right if I remember it. Hopefully. Of course, you don't have to do it by hand. You just can put it in the calculator, or you can even, of course, directly use Excel in order to solve this. Okay, so what else? Calculate the probability that within a sample of 9 you have at least 8 correct joules. So here we have the probability, in order to be consistent, that K equals 3. This was A. And now we want to calculate the probability that at least 8 are correct. So it is K larger than or equal 8. How do we do this? Any idea? Again, it is still the same binomial distribution. No? You just have to put this in this formula of your distribution. So we obtain the sum of K equals 8 up to 12 K over N P to the power of K 1 minus P to the power of N minus K. Well, of course, and this will be a bit handy to calculate this by hand, but we are quite further in the time, so I ask you do it in Excel. So this would be then 8 over 12. Oh, here we have to put in a 12. 0.75 up to 8, 0.25 to the power of 4 plus 9 over 12, 0.759, 0.253, and so on, up to K equals 12. And the last one, C. Calculate the expected value, variance, and standard deviation. This is quite simple. Just look in your notes. In your exam, of course, you are allowed to have a sheet of paper with all the formulas and so on. I'm not quite sure. In one case, I give you some sheet of paper with the formulas, or we are here in a master's, we are here in the advanced course, so maybe I say just create your own sheet of paper. Because what I want to see afterwards in your exam is that you know which formula you have to use and not which formulas you have recapitulated so that you don't have to look it up. So expected value was just of x is np, and the variance of x was n times p times 1 minus p. And then the standard deviation is just the square root of variance. So square root of np1 minus p. So here is 12 times 3 over 4. So we have 3 is 3. We have 9, and here we have then 9 times 1 over 4 is 9 over 4, and here we have 3/2. Okay. Oops. I have to save my document. Next one. Oh, that's normal distributions. Great. Cacao producer. He is filling up his packages, and usually also he writes on his packages that within the package are 125 grams, but unfortunately you make some errors with your filling machines or something else. And actually you know that the weight of your package is actually normally distributed with an expected value of 125 grams and a variance of 25 grams. So what is the probability of a package to be exactly 125 grams if we assume that our packages, the weight is randomly distributed? So we have here a continuous distribution. And recapitulate, what is the probability of a random variable continuously distributed to have exactly one value? So our density, of course, looks like this. 125 f of x and x. Hmm? And this one you really have to keep in mind because this is quite counterintuitively. Because the probability of x equals 125 is just 0. But the probability to be 0 doesn't mean that this event doesn't exist. This is just the difference between discrete random distributions and continuous random distributions. In a discrete random distribution, you really have a finite probability, and here the probability is 0, but this doesn't mean that there exist no packages with 125 grams. But from the theory of statistics, the probability mass of this event x equals 125. This is in a continuous, if we assume a continuous distribution, then the probability mass is 0. Because in the other way around, if you have, since the real numbers are overcountable, you would have to calculate, so to speak, or in quotation marks, um, infinite, more than infinite numbers with a finite positive probability, and then you couldn't end up with 100% of all events. So, but this is anyway more from a philosophical point of view. Then go to practice, and we want to know the probability that 120 is smaller than x is smaller than 130. What do we do here? Well, of course, we can go in our statistics program. We just put in expected value, variance, give the two numbers, and we are done. Then we obtain, I don't know, 25% or something like this. But what do we do here? This is our random distribution, 125. Oops. Mm. So we have here 120 maybe, and here 130. So what we want to calculate is just the area below here. And if we don't have our software package, then we switch to the standard distribution, normal distribution. And now we have to calculate the new interval. What equals in the standard distribution our 120? Here we have, this is the 0, and now we need these two numbers. And what do we do? Remember, that equals x minus, oh, my screen is again back. Good. Minus mu over sigma. Great. So the 120, so I said set D for set down is 120 minus 125, and you of course took the square root. Great, is just 1. Of course, we know that this is symmetrically around 125. Then, of course, we have to be symmetric around 0, and we here at 1. And now, where I have my tables, at least I want to show you the tables, but there we go. The table I also hopefully already uploaded, or am I right? I uploaded you the normally distribution in the tabular form. This table you see, you have. Hopp. Wo müssen wir hin? There. Did I forget it? I don't think so. Let me see if I did it or if I didn't do it. Here we are. Lectures, statistics. Here we are. Okay. What do we have to do is now just look for the cumulated values in our normally distributed random variable. So we look up at 1. X is 1. Up. 2. Ist nicht. Oops. This is a new program. Sorry. So 1. And so we have here our 84.1%. And this 84.1% now we have to interpret. So we know phi of 1 is 84.1%. This means, and this I think you really should practice, that this probability is 84.1%. Oh, sorry, not this. No, I did it wrong. This probability up to here, how do I come back? So this probability from here up to 1 minus 1 plus 1 is 84.1%. So this probability here is then 15.9%. Also, this probability here is 15.9%. So what is then the area here? And the area here equals this area here. Then what is the probability of 120 smaller than x smaller than 130? Should be then 100% minus 2 times 59%, and this is 32, 68.2. Am I right? Great. So I think we will then do only this first sheet of exercise today. So let's do C. probability P of x smaller than 110. Again, I think it is really helpful if you always keep in mind which areas do I calculate. So here 110, 125, so I'm interested in this area. Again, if we transform this probability in the standard distribution, this equals z smaller than what? Maybe here we should also write P of minus 1 smaller z smaller 1. 110 translate into which number in the standard normal distribution? Again, you have just to take this formula. This is 3, yes. Almost. Minus 3, great. So, and then, of course, if we want to really do it by hand with this table, I will do the other questions with you in Excel, but I think you should have seen the tables if you haven't seen them in your introductory courses. Again, I ask you, you really don't talked in detail about the normal distribution in Introduction to Statistics? Anyway, so then we also can say that 100% minus the cumulative function with the number of 3, because I told you in this table you find only the positive numbers, of course, because we know that they are symmetric. So you also should be able to make these simple transformations which we made here. And now we can look up this value here. We can look up, and then we know that this area here, 1 minus the purple area, is equal to the area which we are interested in. And therefore 1 minus phi of 3. We go again in our table. Then I have to go down. Where do we have our 3? It's just here. And 99.86%. So we obtain equals 1 minus 99.86% equals 0.14%. Here we go. Then we have D is probability of X larger than 140. Graphically, again, 125, 140. We are interested in this number. Hopefully you directly can give me the probability. Very surprisingly. I should change the question, I think. What is the probability that our package is larger, is our package, the weight of our package is larger than 140? The same, of course. Because now 140 minus 125 is 15, divided by 5 is of course 3, so we obtain 99.86%. And oh, E is interesting. Then we have E, probability 95%, so 95% equals what calculates a symmetric interval. I think I go to the next slide. So E. Graphically, what we want to do now is 125 f of x, x, and now we do not know the numbers of our interval. Let's say this is x down and this is x up. This is the question, but we know that the area here is 95%. So if we write it down, we have 95% is the probability of x down smaller than x, smaller than x up. And these numbers we want to know. What do we do now? I will switch. Oh no, it's here. Maybe then you have an idea. If I show you this picture, why does it help? This is a density with some numbers of the standard normal distribution. Great! We just use Z, and which numbers do we need here from this picture? Yes, great. So here, we are interested in this interval. So if we make graphically the same as before, only now we don't know these numbers, we translate this picture into the standard distribution. And here we know minus 1.6, and now you already can in the background, because we are quite late, what are these numbers xa and xd and xu plus 9.6. And again we use z equals x minus u over sigma, and zu Zd is equal minus 1.6 and set up is equals 1.96. So if we put this in, then we have minus 1.96 equals xd minus 125 over 5, and then we get roughly, let's say, 5 times minus 2 plus 125 equals xd. So xd is roughly 115. Great, you are better than me. So we do it exactly. And then, of course, the other way around, we are symmetric. So we get this to 134.8. Great. So do we, the last one, sketch graphically. Okay, then we are done. Let's see. Should we do also the other question? There we go here. Some minutes we have still. And let's go here. Tip, tip. I sketch you the first question, A. Mu is 10, 8, and 14. So we are interested in this area. Translate this into the normal distribution. Oop. So we need these two numbers. What equals 8 and what equals 12. Again, z equals x minus mu over sigma. One for this. Is it 1? Minus 1, yes. And the other one? The upper limit? Oh, not here. I made a mistake, sorry. This is not, because here I have a 14. Sorry. If we have our 14, 2, of course. So just we look up the 2. Yeah, zap 2 is here. 97.7%. So we have phi of 2 is 97.7% and phi of 1 was 84.1, I think, no? And then P of 8 smaller than x smaller than 14. Shit. Second time always my second monitor does something wrong. But you see, everything still. You still see everything, yes? Because I have here, okay, I have some hardware problem that my second monitor does anything, I don't know. But anyway, this I think, can get together today. What is then the probability? So we know that this probability here is 1 minus phi of 1. And this probability here is 1 minus phi of 2. So 1 minus phi of, oops, 1 minus this area here, phi of 2, plus phi, no, sorry, no, I'm too fast. Let's see. 100% is everything. So this area is 1 minus phi of 1. So 1 minus phi of 1 plus this area here is 1 minus phi of 2. This means 1 minus 1 cancels out. Oh, 1 minus phi of 1 minus phi of 2. This cannot be true. Again, I did something wrong. What did I do wrong? This area here. Shouldn't be. Where is my fault? Okay, I found it, my fault. Because here we have a minus sign in front of, and so we have phi of 1 plus phi of 2 minus 1 is roughly 84 and 101, 181, 181.8, 81.8%. Do you have this too? Great. So then homework. This first part is quite easy. They are statistically independent. There we know from our first question today, if events are statistically independent, we can just multiply it. And here, this is a quite nice question. Here you have also to take binomial distribution and the probability for your binomial distribution, which we had in the former questions, you get from the normal distributions. So try it, and then we will do these last questions and the other questions about testing and estimation in the next lesson. Thank you very much. This was really great that you, although we were only two students and me, that we had this interaction in an online lecture. This is really nice. Okay. You see, I'm more or less back again, but anyway, I have this problem with my hardware, and I don't know if I can go next week in the lecture hall because I have to ask if it is possible that I enter into the network of the university and the logistics in the lecture halls, that I still can stream or record my lectures with my private laptop. This I don't know. So I just ask you two guys, of course, if I go anyway into the lecture hall, then the lecture won't be recorded and there won't be any Zoom meeting. This we can also do. I don't know. But there are still some other guys. I think, I don't know why they are not in today, but I think there will be around 5 or 10 guys. What do you think? Should we still do it via Zoom and parallel? Anything worked for you? Okay. Well, I think in the end, maybe not next week, but in 2 weeks, then I can see you, hopefully, as a real person. I will inform you about this, what we do next week. And I also posed the question, what kind of exam you want to have. Actually, for me, it's, well, anyway, if you do it in presence or as an online exam, it will be what I ask and which content you get, it will be the same, definitely. I still wonder how I can, pose the question that you also, if you want to take Excel or some other statistics software to solve the problems. But the other way around, I will pose my questions in that way that you also can solve them with no problem if you have learned, if you have recapitulated the content of the lecture without using Excel. But I think maybe I have an idea so that you also can use Excel within the exam. I will see. I don't know yet. Okay, then I stop the video.